Since there's no hardware to connect, I'm going to try a little something different. I'm going to try explaining the whole sketch, which is a culmination of all the work that has been done until now, into a single sketch that will be the basis for the remote controlled car with the Arduino. So for starters, you have to include, so yeah, I'm gonna give you, I already showed you in the other episodes how each part of the sketch worked. I'm just going to explain it in a more detailed, because it's easier than explaining it with the subtitles. So considering that you already have an idea of what's going on, we start out by including both libraries of software serial, software serial library and the servo library. The software serial library is to allow you to have two different serial communications simultaneously. Because once you bring in Bluetooth module, you usually had to work with only one serial at a time, or you couldn't upload your sketch. You had to unplug the wires, blah blah blah, so on. But that is already solved for a long time in a very practical way. All you have to do is downware the software serial, use the commands, and you will be able to use your monitor, your serial monitor on your Arduino IDE while you're working with your Arduino project connected to the Bluetooth. So I'll show you how that works along while I explain the sketch. But for now, keep in mind that that's what it's for. Now the servo library, you're already probably familiar with it. It's to work with the servo motors. It allows you to translate the angle into an PWM signal very easily. I hope you're familiar with that by now. So, after you include the libraries, the next thing I do is I create the second serial object. Now to do that, we have to choose two pins from the Arduino. One will act as a receiver pin and the other as a transmitter pin, so that the data can be communicated between two modules. Keep in mind, I have said it multiple times during some episodes I worked with the Bluetooth, that the transmit pin that is connected to the Arduino must have a voltage divider connecting to usually all Bluetooth modules, no matter if it's HC05 or the XB. I have both, and they both have voltage dividers because the Arduino communicates in 5 volts, but the Bluetooth modules communicate in 3.3 volts, which means that continued communication at 5 volts would burn out your Bluetooth module. I show you how to do that voltage divider in a previous episode of this playlist. So, I create my second serial object, and then I create my servo motor object. After that, I start naming my pins. Pins for the LN298, which is the H bridge motor driver that I am using. I have one pin that is going to be used in an interrupter pin. Arduino has 2 interrupter pins, 2 and 3. I'm going to use number 2 with the photo interrupter, as I showed you previously in the episode, that we need to use it to calculate the speed on the car. I don't know. I'll probably just tell you kind of how the interrupts work. I'm not going to explain it, but I'll show you how to use the commands over here. And this is how you start. You name the pin you're going to use. Now keep in mind, each Arduino is different from the Uno to Mega. Each one has their own pins. On the Uno, which is the one that I'm using right here, it is number 2 and number 3. Now next, I set in my variables. We're going to use 2 variables that are going to count each photo interrupter impulse. One is going to be used, the photo count is going to be used to calculate the speed, and the photo total count will be used to calculate total distance. Next, I input the variables I'm going to use for the time recording. Now, it's good to use long because these numbers can reach very high, and the simple integer command will not have memory enough to record those numbers. So long is, or unsigned long, should use one of those. Then, since we're going to use some formulas to calculate the speed, I use floats so I can have at least 2 decimal points and a larger memory to work in the formula. I use the float for speed and the speed average. The speed count used in the cycle, in one of the cycles of the speed calculations. You'll see it later on. So here we go. The total distance is going to be a very big number. It counts in millimeters. I then divide it by 1,000 when I want to print it, and it will show me the results in meters. Then we have these 2 variables for the speeds, either front or backwards. And then we have the variable turn, which is going to be used for the angle of the servo motor, and I start it at 90, obviously to keep start the car straight. Now, moving into the setup, I initiate the serial communication of my HC05, which I call it HC new car. I begin at 9600 baud rate. You can choose other baud rates. This is enough for me for this case. And then I also start the serial communication. So, proceeding, I attach the servo motor. I call it steering to the pin 9. And then I start my other pin modes for the LN298, for the H bridge motor driver. And this is how I start the interruption. How I bring it into the sketch, how we bring it into the sketch. We attach the interrupt pin with this command. This was pin number 2. As you can see on the screen, it shows a value. This Arduino IDE is very nice. And then you put the name of the function, which I have already written down, the function that is going to be used each time the interrupt is activated. And I chose the mode falling because this is a photo interrupter. Now it's going to change state twice each time the slot passes in front of it, which is on and off, but you only want him to count 1. You can use either falling or rising. You can't use changing. Changing is for other situations.